In Activity 5, Mixing Light Beams, students observe the process of additive color mixing, compare it with subtractive color mixing, and begin to explore the role our eyes and brain play in the perception of color. They use color filters and flashlights to create colored beams of light, then combine different colored beams of light on a white screen. You will need the following materials from the kit: Activity Sheet 5, colored filters, flashlights with frosted acetate, and paper screens from Activity 4. To prepare for the activity, make a copy of Activity Sheet 5 for each student. Each team of 4 will need 2 flashlights, a paper screen, and a set of 6 color filters. To begin the activity, remind students that in Activity 4, they overlap 2 or more filters and passed a single beam of white light through them. Inform students that this time they will create 2 beams of colored light and combine them on the screen. Divide the class into teams of 4 and give each student a copy of Activity Sheet 5 and the materials to each team. Then ask students what you expect will happen if you shine red light from one flashlight and green light from another flashlight onto the same place on a white screen. Many students will probably expect the result to be black or dark gray or brown. Have them record their prediction. Encourage them to work together in making their predictions. Next, review the directions on the activity sheets. The folded sheet of white paper will be used as a screen. 2 team members will each hold a flashlight. The other 2 team members will each hold a colored filter in the beam of one of the flashlights. Next, darken the room and instruct teams to begin by using the red and green filters. Remind them to record the results on the activity sheet. Guide the team members holding flashlights to aim the flashlights so that most of the light falls on the same area of the screen. Then tell the students holding filters to place them in the path of the beams. After the teams have finished, turn on the lights and ask students, did the red and green light beams mix to make the color you expected? Most students will probably not have expected to see yellow. Explain that the color they saw on the screen was not actually yellow, but that our brains and eyes perceived it as yellow. Let students know that scientists are still not sure exactly how this happens. Then have the students select several other 2-color combinations. Remind them to record the colors they choose to combine, followed by their predictions of what color they will see by combining them. Darken the room again and have the students conduct their experiments. Explain that other combinations of colored light do not yield such striking results as red and green. For that reason, students may have difficulty identifying or describing the new colors. Encourage them to look very carefully for any new color where the beams overlap. Guide students to suggest improvements in the setup that might allow them to identify their results more easily. One effective technique is to move one flashlight toward and then away from the screen, varying the intensity of the colors. They can also try turning off one flashlight at a time and seeing how the color on the screen changes when it is turned back on. After the students have experimented with other 2-color combinations of light, turn on the lights and ask students, why do you think these results are different from the colors you observed after mixing pigments or overlapping filters? The students may guess that it has something to do with using more than one beam of light this time. Remind the students that when they combined filters or pigments in previous activities, the resulting colors were always dimmer. In this activity, the combined light from 2 flashlights was brighter than the light from either beam alone. Go on to explain that mixing light beams is called additive color mixing because each beam of light adds its color to the mixture. Help students recall what happened when they held the prisms in the sunlight and ask, what do you predict would happen if we mixed all of the colors on the screen? The students should know that mixing all colors of light will produce white light. Then ask students, what do you predict would happen if we mixed just the blue, green, and red light? After they have recorded their predictions, combine the teams so that each group now has 3 flashlights. Darken the room and instruct teams to use 3 flashlights to overlap beams of blue, green, and red light. They should see white light. Explain to students that blue, green, and red are called the primary colors of light because by using only those 3 colors, they can create any color of light, including white. Certain other 3-color combinations of light will also look white, and some students may wonder why those aren't considered primary colors too. Remind them that they have already shown that these filters are not pure and that the filters let many colors of light through. To conclude the activity, collect the materials and return them to the kit. Leave the frosted acetate squares taped to the flashlights, as they will be used again in the next activity. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.